China has rapidly become a leading force in lunar exploration, achieving remarkable advancements in reaching the moon's surface with sophisticated scientific instruments and sample return capabilities. Their recent lunar mission, Chang'e 6, marks a significant step toward a broader Chinese presence on the moon this decade. On May 3rd, a Chinese Long March 5 rocket launched the Chang'e 6 mission, the world's first spacecraft designed to retrieve samples from the moon's far side. About 37 minutes after liftoff, the 8,200 kilograms Chang'e 6 spacecraft stack separated from the rocket, entering its planned orbit of 200 by 380,000 kilometers, initiating a complex 53-day mission involving 4 spacecraft: an orbiter, a lander, an ascender, and a re-entry capsule. On May 8th, the Chang'e 6 spacecraft stack successfully entered an elliptical orbit around the moon, using a 3,000 Newton engine on the orbiter module to perform the braking burn, capturing the spacecraft with lunar gravity. Shortly after, Chang'e 6 deployed Pakistan's 7 kilograms CubeSat, iCubeQ, in orbit, marking Pakistan's first lunar exploration mission. Developed by Pakistan's Institute of Space Technology with aid from China's Shanghai Jiao Tong University, iCubeQ hosts 2 optical cameras and a magnetometer aimed at detecting potential signs of water ice on the moon's poles. Following a 14-minute descent from an altitude of about 15 kilometers in lunar orbit, Chang'e 6's lander successfully touched down on the moon's far side on June 1st, near the southern rim of the 500 kilometers wide Apollo impact crater. This marked China's 4th successful lunar landing and the 2nd ever far-side lunar touchdown after Chang'e 4. Like modern lunar landers, Chang'e 6 used several key technologies for a safe descent, including a variable thrust engine, optical imagery, onboard maps, hover phases for hazard detection, and shock-absorbing crush core legs for the final fall. The lander also used a laser-based LiDAR sensor to map the local landing area in 3D before the final landing phase, and gamma-ray sensors to measure the height accurately, ensuring a smooth touchdown. Within 1 week, Chang'e 6 collected up to 2 kilograms of soil and rock samples using a drill and a surface scoop, alongside context-providing lander instruments, including cameras, a ground-penetrating radar, and a mineral spectrometer. The lander then transferred the samples to a sealed container and deployed a small 5 kilograms rover to photograph the area. On June 3rd, the samples were launched to lunar orbit via an ascent module, which autonomously docked with the Chang'e 6 orbiter on June 6th. The samples were transferred to the Earth return capsule, which began its journey towards Earth on June 21st and safely landed in China's northern Inner Mongolia Autonomous Region on June 25th. The Chang'e 6 samples, sourced from the Apollo crater embedded in the moon's South Pole-Aitken basin, hold significant scientific value, potentially solving many lunar mysteries. This mission, like its predecessors, was facilitated by the Queqiao-2 Communications Relay Orbiter, which also supports China's upcoming Chang'e 7 and Chang'e 8 missions, targeting launches in 2026 and 2028, respectively. The Chang'e 7 mission will explore the moon's south pole, deploying a rover and hoppers to sample materials from permanently shadowed areas. The mission will carry instruments to map the local subsurface, measure the magnetic field, and analyze lunar materials. It will also host international scientific instruments from Europe, Russia, Thailand, Egypt, and Bahrain, fostering global collaboration. Following Chang'e 7, the Chang'e 8 mission in 2028 will further explore the moon's south pole, focusing on testing technologies for lunar resource utilization, such as 3D printing parts from lunar soil. This mission aims to pave the way for human lunar exploration by the end of the decade. China's systematic progress in lunar exploration has led to significant milestones, from the initial orbiters and landers to the recent Far-Side sample return mission. Their plans for the future include building a long-term moon base, the International Lunar Research Station, ILRS, with both surface and orbital components, and developing new super-heavy lift rockets like the Long March 9 for sustained lunar exploration and resource utilization. China's approach to utilizing lunar resources aligns with international law, fostering potential dialogue for cooperative resource governance. Their lunar ambitions include a mix of scientific research, technology, demonstration, and international collaboration, aiming to lead humanity's exploration and utilization of the moon's resources. Stay tuned as we witness the dawn of a new era in our quest to explore the cosmos. Thank you for joining us, and don't forget to subscribe for more updates on humanity's journey to the stars.